Now, the second way of finding the inverse is to use these. So I'm going to, in this case, use this one. I'm going to say that f of the inverse of fx must equal x. In this case, I know that f of x equals 3 lots of x plus 1. So if I'm putting in the inverse, I'm going to end up with 3 lots of the inverse of x plus 5, and that's got to equal x. So now doing some rearranging, again minusing 5 off both sides. Oh, I've noticed I made a mistake back here. That should be a minus, and that should be a minus. Sorry about that. And now dividing by 3, I get x minus 5 over 3. Now this turns out, in this, when we do it, f of inverse x, be equivalent to just swapping x and y's, and it tends to be easier to write x's and y's. So I recommend that you do this method. Very occasionally it might turn out that this here will give us a quicker, easier way of doing it, but very rarely. Now, if you are asked about the domain and range of your inverse, well, because your function takes in some values and it's going to pop out all the values which is in your range, your inverse is going to take all those range. So the domain of your inverse must equal the range of your original function. Because it must take all the values you could have popped out and turn them back, and our range of our inverse is going to turn out to be the domain of our original function. Now, let's just have a look at this graphically for a moment. So let's say I had some function that looks, I don't know, like that graphically. And I want to work out what the inverse is graphically. Well, let's just get a couple of values. So if I put in this x, I'll just write that this is my f of x. So if I put in, say, this x value here, that's going to pop out with this y value. Now, in order to be the inverse, it's going to have to take this x value, whatever that is, so it's about here, and pop out whatever that y value is. So it must go from here to here. So this point here must be in our inverse. And we can sort of trace a few other points. So maybe I do a point here. So about this far out, it's going to be about here. And I start to put a bunch of points together. And what I find is that my inverse is always just a reflection through a line y equals x. And that could be another really useful way of thinking about the inverse.